Alrighty, so today we're going to be looking at determining the sequence from non-sequential terms. So we've been given T5 and T9, and we want to know what, say, the first couple of terms of the sequence are. Let's say we're looking for the first 4 terms. Alright, problem, I don't know what T1 is, I don't know what D is, but I do know what these 2 terms are. Similar to when we were doing this in arithmetic sequences, we can substitute the information we do know and use simultaneous equations. So using this, we know that n is equal to 5 and Tn is equal to 162. So we get 162 is equal to T1 r to the 5 minus 1, which for those of you who are quick, 5 minus 1 is 4. Same thing over here. Tn equals T1 r to the n minus 1. N is equal to 9, T of n is equal to 13,122. 13,122 on the left is equal to T1 r to the 9 minus 1, which is 8. So 9 minus 1 is 8. So this is equation 1, and this is equation 2. Now we're ready to solve. However, subtraction is not going to work here, because if we subtract these things, they're not like terms. This is to the power of 4, this is to the power of 8. That's not going to work. However, if we divided these things, well, we would have T1 on the top, T1 on the bottom, and that would actually simplify. So let's go 2 divided by 1, and that gives us equation 2. Oh, notice again, I'm putting the larger equation on top. In particular, I want the larger r on top, largest r on top. So we're going to get 13,122 T1 r to the 8 over 162 T1 r to the 4. Notice it's literally equation 2 on top of equation 1. Right? Left-hand side divided by left-hand side, right-hand side divided by right-hand side. How does this simplify? Well, the T1 cancels with the T1, so that just disappears. Then I'm left with R8 over R4. And on the left-hand side, that's just a fraction, so 13,122 over 162 just leaves me with 81. Okay? Now we can actually simplify this using our indice laws. R to the 8 divided by R to the 4. Well, just as a reminder, you wouldn't actually do this, but it's R times R times R times R times R dot 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 times R 8 times over R times R times R times R. 1 cancels, 1 cancels, 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 and I'm left with 4 r's on top, so it's r to the power of 4. Really what we do is we just go r to the 8 minus 4, which is r to the 4. And so we get 81 is equal to r to the 4. And we've nearly found the common ratio. Now, just as a reminder, the opposite of to the power of 4 is the 4th root. So we're going to take the 4th root of both sides here. That cancels on the right-hand side, so we're just left with r on the right-hand side. And on the left-hand side, ooh, wait, just be careful. Anytime you take an even root, meaning a square root, a 4th root, the 6th root, the 8th root, you need to add a plus or minus symbol, because it could have been plus or it could have been minus. The 4th root of 81 is just 3, and so we get plus or minus 3. Now we could go through and solve this 2 different ways, but what we usually do is we say, assume the positive root, meaning we're assuming r is equal to 3 and not negative 3. This is an assumption, and you need to state it. We don't know that r should be positive. However, most questions will tell you if you get plus or minus, then assume the positive common ratio. Alright, so Now that we've got that, the only thing we're left with is we need to go back and find T1. Now you've got two equations there. My favorite equation is going to be number 1 because it's a little bit simpler. So let's sub r equals 3 into 1. So it's 162 on the left-hand side equals T1 times 3 to the n, 3 to the 4th power. 3 to the 4 is just 81, so we get 162 is equal to 81 T1. Divide both sides by 81. And you get that T1 is equal to 2. So I now know T1, and I now know common ratio is 3. So we get T1 equals 2. T2 is equal to 2 times the common ratio 3. That's 6. T3 times 3 again, 18. And T4 is going to be 18 times 3, which is 54. And you could repeat this, right? Because we knew that right at the very beginning, we found out that T5 was 162. And indeed, T5 is 54 times 3, which is 162. So we have worked out the sequence which worked. Now this would have worked if we had chosen r equals -3, and it would have generated a perfectly valid sequence. But generally speaking, we're going to assume the positive root. You still have to write the plus or minus, but then you just assume that the positive root, meaning you take only the positive answer. You don't leave the plus or minus. Alrighty, so that's how you find non-sequential terms in a geometric sequence. It's just simultaneous equations, but with division. See you in the next one.